attempting another freeCodeCamp project. I will leave the link in the description down below. It's called Probability Calculator. But yeah, let's take a look. I have all the code ready to go. And yeah, let's read the instruction. Suppose there is a hat containing 5 blue balls, 4 red balls, and 2 green balls. What is the probability that a random draw of 4 balls will contain at least 1 red ball and 2 green balls? While it would be possible to calculate the probability using advanced mathematics, otherwise known as Math 2, an easier way is to write a program to perform a large number of experiments to estimate an approximate probability. For this project, you will write a program to determine the approximate probability of drawing certain balls randomly from a hat. First, create a hat class in probCalculator.py. The class should take in a variable number of argument. We've really done this in like past project, but this is a good time to talk about something called quarks, args and quarks. I will get to it later. But yeah, for example, class object can be created in these ways. A hat will always be created with at least 1 ball. And hat? Okay. The argument passed into the hat object upon creation should be converted to a contents instance variable. Contents should be a list of strings containing 1 item for each ball in the hat. Each item in the list should be a color name representing a single ball of that color. For example, if your hat is red 2, blue 1, content should be red, red, blue. The hat class should also have a draw method that accepts an argument indicating the number of balls to draw from the hat. The method should remove ball at random from contents and return those balls as a list of string. The ball should not go back into the hat during the draw, similar to a earn experiment without replacement. If the number of balls to draw exceeds the available quantity, then return all balls. Next, create. Okay, so we'll implement the hat class first. So for a class, right, we need to have our constructor. And since in this case it's a little bit special, we can take in, it's going to be quarks, right? And if you are not familiar with quarks, we can just print this out and I can show you what that exactly does. And for now, I'll pass. Okay, so here's what I would do. In here, I will do Python -i, and let's say probCalculator.py. So that -i basically will load all of these method, class, functions, whatever, into the little console environment I have here. And let's go and try to create a new hat object. Okay, so okay, so let's see if that will work. I didn't really use quarks that much, so I'm not sure. I don't really know how to really use it. Okay, so perfect. Yeah, you need to convert to a dictionary. So we can convert it to a dictionary. So quarks stands for keyword arguments. Asterisk quarks, that basically will allow you to take in infinite many amount of keyword arguments we can have. Okay, we can take an infinite amount of keyword arguments we can have. And in here, we're going to have a contents list, right? Contents array or list. So then in here, we're going to say for, what do you call them? What do you call this? Okay, for color. All right. For color in, so now just call it. So this will just be what should we call it? Contents. So ball count. Let's call it ball count. Ball count. Oh my god, this is failing. Okay. For color, for color in ball count. Print color. Okay. And then we're not, yeah, so we're actually, let's just do contents. Oh, what am I doing? In ball count, ball count dot keys. So dot keys will actually give us all the key values, and in the list format, well, not exactly in the list format, but I guess I can convert to a list. It's technically called dict key type, so it's a little bit weird, but I can convert it to this. Okay, so now contents bracket. So then here's what I want to do. I need to do a nested loop, right? And then for underscore, because I don't really care about using that variable, in range of what? Ball count bracket color, and then we can do contents dot append color, and then we can do self dot contents equals contents, like that. So now we have set up our constructor, right? See, we have a contents list. We then convert this keyword argument to a dictionary format like that, and then we loop through the colors, right? And then for each of the color, then we have a range, and then we just append it based on what's a number here. That's how many times we're gonna append the color into the contents list. Perfect. Okay. All right, next, the hat class should have a draw method that accepts an argument indicating the number of balls to draw from the hat. Okay, the method should remove balls at random from contents and should return those balls as a list of strings. The ball should not go back. Okay, so then there's multiple approach to do this, right? But my idea would just be self. So self will always be the first argument in a class because that's how I can get access to all these instance variables. Okay, so on draw, let's say num balls, right? That's how many balls I want to draw. So I believe there's one check. If the number of balls to draw exceeds the available quantity, return all balls, right? So that means if num balls, we'll do that as like a precondition, just like to check. So greater than or equals to self.contents.length return as a list of strings, right? List of strings. So I'm gonna just return self.contents. Perfect. Yeah, if numball greater than or equals to self.contents.length return self.contents. Okay. Otherwise, we're gonna go into a loop. So for any range of numballs, that can also be an underscore. We don't really care about this variable that much. Okay, so here's what's gonna happen. We're gonna generate a random num, right? We're gonna generate a random integer from 0 to, since it's inclusive on both ends, then I can do from 0 to what? Numballs. Numballs dot, or not numballs. I can do self.contents. Did I do dot length? I'm sorry. It should be len. Yeah. Like that. Yeah, this is what happened when we're doing project multiple programming language, they start to get messed up. Yeah, Python's really weird. nearly all other programming languages don't have a specific method to get a length of an iterable object, but Python does. Oh well. Okay, so what that does is that will give me a random integer between 0 to the length of the self.contents, to the length basically to the length of this contents list, right? To all the possibility I have. Okay, so then I just want to do, let's say, results. And then we can say contents. That's what will be the contents we're working with, but I think we don't want to modify it directly. We probably, do we want to modify it directly? Maybe we can just modify them. I don't know, it didn't really be specific on that. Maybe we can just modify the list. Anyway, so we can say results dot append self dot contents dot pop. No. Right, because num is like the index. We can pop that index in our self dot content, and turns out pop actually return the elements that's removed, so that's perfect. And then we can return results like that. Okay, so according to this, and that's done. Okay, let's press run. I don't know how the test goes. Okay. Probability none. Okay, maybe I didn't need to finish the experiment method first. All right, let's look at the experiment method then. More function. So next, create an experiment function. This function should accept the following argument: hat, a hat object containing balls that should be copied inside the function. Expected balls, an object indicating the exact group of balls attempt to draw from the hat for the experiment. For example, to determine the probability of drawing 2 blue balls and 1 ball, set the expected to blue 2, not ball drawn. Okay. Experiment should determine probability. For example, if you got at least 2 red balls and 1 green balls. Okay. Okay, so we string start have specified ball, drawing several balls. Yeah, okay. So then I don't want to remove it from contents because I'm using the same object. Right? So then say contents equals self dot contents. And then this can just be contents because why not? Yeah, like that. So then we didn't really touch self dot contents anymore. Oh yeah, this also need to be just contents. Okay, so now basically we just want to call this method for this many times, right? So for underscore in range of num experiments, right? I'm going to call it this many times. So basically I just want to say, okay, hat dot draw. And then if I can spell, or I can copy paste like that. Okay, so hat dot draw. So expected ball. Okay, what's the difference between these two? Okay, expected ball, number of ball to draw out. Okay, perfect. So it does tell us, so we can just use this. And we can draw that many balls. Where you can draw that many balls. Okay, so let's see. So let's see. So once I did that, that will give me the balls that we drew. right? So now I guess the question is, how do we compare it with the dictionary, right? So let's see. So I guess the question we're facing is, okay, so the question we're facing is, how should we compare the dictionary values? So I guess I have a couple ways to do that. I can get the color, get the color. Oh my god, how did I do this actually? Okay, I get the color. All right, let's think about it this way. So balls will return us a list, right? So I guess what I will do is I will convert expected balls to uh, this. Okay, so let's do this. For expected color in list expected balls dot keys. Is keys? Yeah, keys. Okay. So then expected color is that, and now I want to do, I can do a count, right? Balls dot count. I can count exp color. So let's say actual. So let's say expected is expected balls bracket expected color. We're not. I could just do color. I don't need to spell extra stuff that I don't want to. Okay, so let's see. What should I do? If our actual ball is greater than expected, if our actual ball, let me think. If our actual ball is greater than expected, then that's good. Or greater than equals to, then that's good. Or actually, we can count success. If it's less than, I will just I'll break. I believe for loop has something called else you can use. So basically, that will only run if the loop has quitted properly. So in this case, if it breaks, it's not like terminating properly. So it will not go to the else part. If it did terminate properly, right? So that means actually went here, nothing broke, nothing like it broke. Then it's gonna go to the else part. So then I can just write successes plus equals 1. And then I want to return success over, or no, I mean experiments, because that's how many experiments I did. Okay, let's see what bug doing to fix. Okay, pop index out of range. Great. So line 24. Had we not updated? Okay. It's length of contents minus 1. Because yeah, it's inclusive on both ends. So length of content minus 1. Okay. So it always broke? I don't believe this. Okay. Okay. That's weird. Let's see. Ball, hats. Hat the draw. Now we'll draw that mini ball. For coloring expected. Dot count. Okay, let's see. Print actual, comma, expected. So I want to see what's the actual, what's the expected. Yeah, okay. Wait, let's see. It's always 0, 2. That is really weird. Let's see. So let's see what's our self.content. Hats has no, yeah. Self.contents. Let's take a look why this isn't aligning up. Blue, blue, red, red, red. That's weird. Blue, red, 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 blue, 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 blue. Oh, wait. Why would that happen? Alright, let's. So I think that the logic is right. Okay, so dot keys. There might be multiple keys. Well, no, they're not going to be multiple keys. Balls dot count. Okay, so expected. I don't know what their non-experiment sets to. Okay, so red, red, green, green. It's always red, red, green, green. That's weird. Okay, let's look at their test, what they initialized it to. So expected, yeah, that has draw. Wait, what? Wait, I don't get that part. Oh. So what are we doing here? Okay. Then probability. Okay, so why is that 0? Yeah. Maybe I shouldn't do this? That doesn't really make any sense. But I mean, I can. That doesn't make any sense. Okay, it didn't change anything. I mean, okay. So still failed the experiment part. Okay, so let's see. This is so random. What the heck? Let me just asterisk that and let's just press run. So it's 0. Okay. Why is it 0? We're gonna draw 4 balls. So we keep drawing red and green. First of all, how do we draw? Okay, we have green. Why do we constantly draw red and green? That doesn't make any sense. Oh, okay. This part. This part is why it's returning all of them. But, yeah, see, that's why I think we should have another variable. Okay, so in theory that shouldn't change anything. Why is it the 4 thing still get triggered? Maybe I need to copy it. Okay, I don't really understand. Okay, looks like we need to use this copy then. Whatever. Let's just do copy.copy. Okay, now that's giving us some difference. Variety at least. Okay. Okay, that gave us some different variety. Alright, so yeah, looks like because how we copied it, because looks like Python is a promise reference. So self.content, I'm still removing the thing from self.content, so that's not good. Okay, so now let me uncomment out my code in the main module. Let's see if it's gonna run now. Okay, expected hat draw to reduce number of items in contents. How? How do you make... Okay. Yeah, so that means we're not going to copy that. We're not going to hard copy that. We're going to hard copy balls. We're going to hard copy hat. I mean, we're going to hard copy, copy hat. So then every time we have the new hat that we're working with. Okay, so let's create like original hat. And then we're just going to do copy dot copy hat. Okay. Now what I'm gonna do here is I'm a right hat is gonna be copy dot copy original hat. And then I'm gonna use the original hat to draw. Okay. Yeah. So then this part I don't need you. And then that's still self dot contents. Self dot contents. Like that. Let's run it. Yeah, now we're just back to where it started. Original hat, copy dot copy hat, copy dot copy original hat. What about deep copy? I don't really know the difference between copy and deep copy. This is the first time I'm using the copy. Okay, looks like this may some difference. I don't know. Something you just have to try. Okay. Give us okay. So looks like we're good. So I guess what it really tested us on is the ability to do deep copy. I don't know. Copy worked on like list, but deep copy you need to make it maybe like object. I'm not quite sure, but this is not that too complicated. Again, what we did, just a final recap, is we have a hat, we have a constructor, right? We use quarks, keyword arguments, to just take an infinite many of keywords, and then we store them into the contents list. We randomly drew them. We're gonna update we're gonna update the contents list while we're doing them in real time, and then experiments going to handle the copying part. We can loop through the num experiment and then return a decimal of the success. But yeah, that's pretty much it. If you have any question or comment, feel free to comment down below. And as always, thank you for watching. Stay safe and have a good rest of your day. That's me out.